All right, here we are with our second topic in Algebra Basics. It's a big one, simplifying polynomials. Hopefully, once again, familiar to you from a previous college course or from high school, but if not, we're going to kind of bring you back to it. So when I talk about simplifying, I want you to take, something and make it shorter. So it's only this long. You're not going to have an answer. You're not going to have x equals 17, y equals 5. You'll never have one kind of thing. Usually we'll give these to you and you won't see an equal sign, hopefully, but then you may, but Algebra Basics is all simplification. And simplification can be used when you're solving as an intermediate step, but for this unit, we're never going to have those answers. We're just going to make, ideally, things a little cleaner. Sometimes you won't agree that it's cleaner, but I'll tell you what I want from you in these slides. All right, so the first way I'm going to show you how to simplify is by adding and subtracting. And when you talk about like terms, like the thing we always throw around is collecting like terms. When I'm talking about whether terms are like or unlike, I don't care what the number is in front. That's called the coefficient. That doesn't matter. That'll do the math in a minute. I just want to know if I can combine them. And the deal is, if the variables, the x's, the y's, the powers, are identical, then they can be combined. They're called like terms. So when I look at a here, I've got 3x and negative 4x squared. I don't care about the 3 and the negative 4. What I care about is x the same as x squared. No. They're both x's, but this one's to a higher power. And whenever you're asking if things are like or unlike, do a number test, right? Don't use number 1. Don't use the number 0, because those are weird. Use 2 or anything else. So change x to 2. Is 2 the same as 2 squared? Nope. 2 is not the same as 4. So x and x squared are different, and these are unlike. Here I have in B 7y squared and 0.625y squared. We're decimal, integer, that's fine. Y squared and y squared. These are like terms, and they can be combined. In C, I have 8 and 3 for the numbers, don't care, and I have xy and yx. Now here's a question, are those the same? This is a weird situation. They are the same because you're allowed to put anything in any order. And once again, test it with numbers. Is 2 times 4 the same as 4 times 2? Like, does it matter what order your multiplication happens in? No. So xy and yx are the same, and they can be combined. And for the last one, I'm comparing xy and xy squared. So the x's are the same, but y is not the same as y squared. So these are unlike terms, and you cannot combine them. So remember that. That is a hard rule. So when you go to combine terms and make this easier, as long as your variables are the same, you're allowed to do math with the numbers in front. So when I look at this first one, I've got x, 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 x. These are all the same, so I can combine them. So the math I'm going to do is I'm just going to do the math that I see. I see a 3, subtract 4, add 7, and here I don't see a number in front. If you don't see a number in front, it's 1, not 0. Okay, so I get minus 1 plus 7 is 6, minus 1 is 5. And the variable stays the same when you're adding and subtracting. That's not always true. In multiplying and dividing it might not, but adding and subtracting you do. And I guess the way to think about that is if you thought of these as being pineapples or some kind of actual tangible object. If I took 3 pineapples, subtracted 4, added 7, subtracted 1, and ignore the fact that I went into negative pineapples for a little bit there, I'm not going to have like 5 pineapples cubed or to the power of 4. I'm still going to have 5 pineapples. So don't change the variable when you're adding and subtracting like terms. Alright, so these two are the same question. I'll call it B and C, even though they're the same question. And I'm just going to show you two strategies for collecting like terms if you struggle with it. So the first one is having lots of colors. And you just go through and you color any terms that you can gather. Some teachers really like you to rearrange everything. Not a big fan myself, because I feel like the more you rewrite things, the more you make mistakes. So I just color and then make sure I add all the color parts together. And notice I'm coloring in the sign in front because that's the action I'm going to take with it, whether I'm going to add or subtract. So looking at my yellows, I have 3x squared minus 1x squared. So 3 minus 1, 2. Keep the variable. Looking at my pinks, I have minus 4 plus 7. That's positive 3. Positive 3x. And make sure you always have an operator in between those terms. Same question, different approach. List all the types of terms you have. So I can see x squareds and x's. And then do the math for them. So I'm just going to write down the coefficients. I'm going to do 3 minus 1 in the x squared, and I'm going to get 2. And for the x's, I'm going to do minus 4 plus 7, and that's going to give me 3. And that's positive, so they're both positive, so write them down. Just give the variable back. There we go. So let's do some practice. All right, so looking at this first one, what types of terms do I have? I have x's and I have a single y. So I can add the two x coefficients. So 2 plus 3 makes 5x. There's nothing for the y to combine with, so just write it down again as you see it. That's the answer. That's a simplified version of A. Moving to B. I'm going to do the coloring for this one because I like the coloring. I have x's. Here's another x. And then I'm going to color the y's so that I have them separate. I'll drop this step in a second as we go faster. And I'm going to combine, and the z I didn't color, there's nothing for it to combine with. So I know I'm going to have plus z written down in this. So x is like a 1x plus 3. 1 plus 3 is 4. Don't change the variable. Negative 2, subtract another 1 is negative 3y. Good. And don't forget to write down the lonely z. There we go. All right, so for this one, looking at my x squared, I'm just going to use my little underliner here. I see 1 plus 3, 4x squared. And then moving over, looking at my, and sometimes I just do it and cross it out even too as I go along. Looking at my next variable, I have plain old x's, they can combine. 2 minus 5 is minus 3, keep the x the same, cross it off. And then what's left? Just that 1. Now, if I had written this as 1 minus 3x plus 4x squared, that's the same thing. They are equal. However, when you go to do the test, and often in math, they like to have your polynomials listed in what they call descending order. So that's the biggest exponent, in this case we only have x to the 2, followed by the next biggest, x to the 1, and then always numbers, plain old numbers last. All right, looking at D, it's confusing. So I'm going to bring out the colors again. Okay, x, y squared. We'll give that a pink. X, y squared. Here's one. And being very careful, just say it out loud, make sure they're not the same. X squared y. That is not the same as x, y squared. The 2 is on a different letter. X squared y. And then we have a plain xy. That's going to be left over and it will not combine with anything. Back to my pen. Pinks, 2 minus 8, negative 6. Leave the variable. To the greens, negative 6 minus 1. To the no colors. And when you have these kind of mishmash variables, descending order kind of goes out the window. We really just use it if we have x cubed, then x squared, and x, and then it's easy to figure out descending order. Looking at G, I have an x squared, y squared, and I don't have any other one of those. Okay, fine. Then I have an x cubed, y squared, and it's the only one, and I see this pattern continues. Nothing can be combined, and sometimes that happens. So there is no simplification that can happen. You're just going to write down the question again. And finally, H, y squared x is the same as xy squared. I have a single x and a y to the power of 2. So those can combine, watch out. And you can write that down any way you want, as a y squared x or an xy squared, doesn't matter. So 1 plus 2, 3y squared x, which cannot combine when the x is squared and the y is squared. That is different. Alright, so that's simplifying by adding and subtracting, what we call collecting like terms. So next we're going to look at simplifying by multiplying. And we have two types of things, distributing and expansion. Okay, so this first one, we already know how to do. This was just the exponent law stuff we did last class. So you can multiply the 3 by the 7 to make 21. And then the math in your x's will be the addition of the exponents, because that's that exponent law. And the math in your y's will be the addition of the exponents. And it's going to be 21x5, y10. That's fine. Distribution is a little different in that we have a 3x and we want to multiply it by something in bracket that's more than one term. It's not just one term all smashed together within those brackets. So we're going to do that, and then often once we do it, we can do further math and collect like terms. So I'm just going to show you how to distribute on the next slide, but if I were to actually do this math, this whole thing will turn into 3x squared minus 24x. And then I have my leftover pieces, and suddenly I find myself in a place where I can combine a couple of these using simplification by addition subtraction, and I end up with 4x squared minus 24x plus 20. So let's see how we did that distributing. Alright, I'm going to go to more exciting pencils for this one. So when you have something in front, no matter what it is, it gets multiplied by everything in the brackets. So don't multiply the 2 by the x cubed and then forget to multiply it by the negative 7. Super common mistake. And here. So these are all kind of the same, but slightly different. 2 times x cubed, a number times a variable. They are not really going to interact, they're just going to get smashed together. 2 times negative 7, take the sign in front with it, is negative 14. And in this case, we've got a negative 2, but we're going to do the same thing. Negative 2 times x cubed, negative 2x cubed. Negative 2 times negative 7, watch, we'll flip the sign. Negative times negative makes a positive. And in C, we still have our 2, but now we also have a variable component to our first thing. So the 2 still just goes in front, and x cubed here times x to the power of 4, you're going to add those exponents, 4 plus 3, x7. And then multiply it by the 7. 2 times negative 7 is negative 14. And remember that you had an x to the power of the 4. Don't drop that. Bring it with you. So let's practice our distribution. I'm going to flip my page. Hold on. And I'm just going to draw my rainbows in to start. This 3 will multiply by that and that. I've got a double distribution in this one. And I'm going to leave C for a minute because it's crazy, but a total valid test type question. Okay, 3 times 4 is 12. And then there's an x. That's just going to smash together. 3 times negative 8 is negative 24. And there's that y. That just stays there. For b, 2x times x squared. The 2 stays. It becomes x3 because you're adding the 1 to the 2. And then 2x times 5. The 5 and the 2 interact to make 10. And the x comes along for a ride. Negative x squared. And notice I'm taking that negative with it. Times x. Same thing. 2 plus 1. Negative x cubed. Okay. And then negative x squared times negative 3. 2 negatives make a positive. And the x squared stays positive 3x squared. And then we're going to be able to do some further combining in this one. So I'm looking through and I see that I've got a couple of x cubes that can combine. So I'm going to combine them. 2 minus 1 is 1. You can write it in front if you want. Probably best if you just write x cubed. And then we have rearranging, so they're in descending order. 3, 2, 1. Done. Okay, C. Let's switch a color here. So I've got a lot of brackets. I've got brackets within brackets. So I'm going to deal with these inner brackets. I'm going to take this negative 3 and I'm going to distribute it into those middle brackets. And I won't touch anything else yet. So I just rewrite the x squared. I rewrite the subtraction. I leave the 5, distribute the negative 3 to the x, and distribute the negative 3 to the other negative 3, positive 9. I can clean up within these brackets before I do the distribution of the negative. So I'm just going to clean that up. 5 plus 9 is 14. So take as many steps as you want. Now I'm going to take that negative, which is like negative 1, oops, and I'm going to distribute it in to those brackets. So I end up with x squared. 14 times negative 1 is negative 14. Negative 3x times negative 1 is positive 3x. And then I just have the stuff left over. And now I have no brackets left, so it's fair game for combining like terms. X squared plus 20x, because of the 3 and the 17, and minus 6, negative 14 plus 6. Done. The second type of multiplication simplification we do is expansion. So we use that when it's not just distribution, is one chunk going into multi-term, however many chunks. Expansion is when you're got a brackets time of brackets, basically. And the problem with expansion where you can get messed up is you have to take this x and multiply it by the 3x and the 2. And you have to take the negative 4 and multiply it by the 3x and the 2. So it just gets a little messy. So we have some tricks we use for that. And this is completely old school. It comes from quadratics. This could be the factored form of a quadratic, and you would use expansion to go from factored form to standard form. But we won't deal with that this term too much. Or this unit we'll deal with it in factoring. Okay, so what are the ways that you can do it? You can use FOIL, and you'll see what that stands for. First, outside, inside, last. So if I were to take, and I'll do this slowly so we have lots of color. First is the two first things multiplied by each other. And x times 3x is 3x squared. O stands for outside. The two outside things multiplied together. X times 2, 2x. I stands for inside. The two inside things multiplied together. Remember to take that negative with it. Negative 4 times 3, negative 12x. running out of pencils. Here. And last stands for, L stands for last, which is the two last things multiplied together. So I'm going to have negative 4 times positive 2, which is negative 8. So these are all the things that are going to go into my simplification, and at the end I just gather them up together. So my first step would be, hey, 3x squared plus 2x minus 12x minus 8. And my second step is 3x squared minus 10x minus 8. If you have another way of doing this, or you can just do it by looking at it, that's fine. I'm just giving you the long form. The second method you can use, which is very popular in high school right now, is the array. And what you do in the array is you write down your two binomials outside a box. So it doesn't matter which goes where. So this is x, and this is the minus 4 from here. And then 3x plus 2, I don't have to write the positive down, from the second binomial. And then when you do the math for this, you just, like biology, multiply. So 3x times x to get into that first corner box is 3x squared. And then I'm going to make this messy, x times 2, 2x. And going across, 3x times negative 4 makes negative 12x here. And then the last spot is negative 2 times negative 4, positive 2 times negative 4, negative 8. Same numbers or values. Oops, plus 2x minus 12x minus 8, which will give you the same answer. FOIL is great. It's the one I grew up with. I don't use the array that often. The array is great if you're a visual person, but where FOIL has a shortcoming is when you start bringing in trinomials or really big ugly polynomials, then it doesn't work anymore. Okay, because suddenly there's more middle terms and it gets complicated. The nice thing about the array is you can just build this box as big as you need it to be. You could have done 3 up and down by 2 across. It will always work. So here, because I set it up on my computer to be 3 across the top, I'm going to put the trinomial in here. And I'm just going to fill in each box. So across the top, x times x squared, x cubed. Negative 4x times x, negative 4x squared. 3 times x, 3x. And across the bottom, left to right, negative 2 times x squared, negative 2x squared. Negative 4x times negative 2, 8x positive. And 3 times negative 2, negative 6. So our list, and I'm just going to go from in descending order, x squared, and then, x cubed, alright, and when you do it like this, you can just gather, those next two are going to gather, negative 4 minus 2, minus 6x squared, and then for the x's, 8 plus 3 plus 11x, and then we just have a lonely negative 6. So there's the expansion of that nasty thing. I don't even want to read it out. So let's do some practice. So for A, if I use FOIL, the first one is 2x times x, which gives me 2x squared. The outside, 2x times 1. The inside, negative 8 times x. And the last, negative 8 times 1. And that will give us 2x squared minus 6x minus 8. For this second one, there's like some distribution that can happen, and there's some expansion that can happen. In my experience, the way to not mess it up, do the expansion first. then do the distribution. If you are determined to do it the other way, go for it. But I just see so many mistakes happen when people do it the other way. So if we were to do the expansion, and I'm just going to do it separately and then put it back in brackets. So we've got x squared for first. I've got minus 5x for outside. I've got 4x for inside. And I've got negative 20 for last. Cool. So I'm going to just write those down. And then here, and notice I'm going to write down minus x because I took that negative 5 and I added it to the positive 4. I combined the x terms. And then we still have a minus 10x. And now I'm going to do that distribution. So we've done expansion. Personally, next I like distribution. Negative 3x times x squared, negative 3x cubed. Second term is going to be positive. Don't forget the 3. And the x's combined to make x squared. And the last term will be positive. 20 times 3 is 60. And don't forget the x. And now our brackets are gone. And we just have minus 10x. Last step, check the order. And we can combine the two x terms, 60 minus 10. Excellent. Okay, and the last one's super important because it's always done wrong. So when you see this, trust me, the answer is not 9x squared plus 49. Not that answer. Because when you see this, when it's squared, that just means whatever the base is by the itself. And the base here is 3x plus 7. So you must write this like that and use your FOIL or your array, and you're doing an expansion. First, 9x squared. Outside, 7 times 3x, 21x. Inside, these ones it's always the same, another 21x. And last, 49. Okay, so we get the 9x squared and the 49 in there, but we also have an x term that everyone likes to forget. So 9x squared plus 42x plus 49. All right, last topic, simplifying by dividing. So when you get these questions, they come to you as fractions, and you'll either cancel common factors to simplify, which is kind of like our exponent law stuff. And that happens when you only have one term. So this mess here is one term. This mess is one term. So this is just going to be canceling or exponent laws or whatever you want to call it. Here, the numerator in situation 2 has two terms. Right? This 2x squared y is separate than the 6x4. So you're actually going to break the fractions apart and do the math. So let's look at how that happens. Okay. So when I look at the type 1 here, I'm just going to exponent law this bad Larry. I have a negative 18, and I have x's on the top and the bottom, and the math for the x's, 7 minus 1. And the math for the y's, 3 minus 2, using that rule of division where you subtract the exponents if the variables or numbers are divided. And then my final answer for the first one, okay. Now looking at the second one, I'm just going to start by being like, what's different? Like, what doesn't have anybody to hang out with? I only see one x, and x minus 3 is different than x plus 3. And once again, using that test, if I make x a number, are they the same? If x is 10, x minus 3 is 7, x plus 3 is 13. So those binomials are not the same, so you can't combine them. So I know, just kind of cheaty looking at it here, that my answer is going to have a plain old x, and it's definitely going to have a binomial on the bottom. That's x minus 3, just because I can't simplify, cancel, use exponent laws. So what else do I see? I see 2 over 4, which is essentially 1 over 2. And then I see x plus 3, and there's 4 of them on the top and 2 at the bottom. So you can either just cancel, or you can be like, exponent law, there's going to be 2 left. or to the power of 2, it's positive, so that means it goes on the top. So that means for my numbers, 1 over 2, I just have to put a 2 at the bottom. And from my binomial, x plus 3 squared. Done. Messy, but done. Okay, let's kind of clean it up here. Okay, so type 2. So the logic behind this is that you're allowed to split these apart, because when you remember just numbers, if you had 3 over 6 plus 1 over 6, you could put the 2, if the denominators were the same, you could put the 2 together, numerators together like that, and then you're going to make 4 over 6, which comes down to 2 over 3. So here's the thing. If I've got a 2x in the bottom and both of them are over 2x, I can split them apart. So this is the only time in simplifying that I'm going to ask you to split things apart. And you're never going to put them back together for the simplification type. And you're going to simplify each fraction separately. So I'm going to do this one with a bit more cancel style. 2 over 2 is 1. Now, x squared over x, we'll leave an x in the thing. So our first term is just going to be x, y. 6 over 2 is 3. x4 over x, that disappears. 3 left. xy minus 3x cubed. Sometimes these end up having a fraction in one of them. That's fine. Don't put them back together, or else you'll end up where you started. So that's the answer we want for this simplification. So let's do our last slide, which may involve me moving stuff onto the next page. I'm not sure if we can fit it all. Yeah, okay. So this first example is busy, because there's some stuff I want to clean up in the top before I even get going. I want to use my exponent laws to combine these. So I see that I have 15x squared, that's fine. And I'm just going to move the 2y over here, because what I want to deal with is this 4bx, because it is squared on the outside. That means I have to square everything in the bracket. So 16b squared x squared on the top, sorry. And that's all over 30 xy. Okay, so you could multiply all the numbers together, get something really big and gross, see if it's divisible by 30, or you can also just be like, oh hey, 15 times 2 is 30. So I've got 30 right here. So 30 here cancels with 30 there. And then it's just a matter of combining everything else. Maybe I'll do another fraction. So I've got that 16, and I've got x4 on the top from here and here. And I put my things out of order. I've got b squared, and I've got a single y. And that's all over. I'm definitely going to have to make another slide. bxy. Okay, so switch colors again, because this is messy. So when I look at this, I see that 16 is fine. This is going to drop to 3. This will disappear. x3, exponent laws are just canceling. This will drop to a plain b. And y over y is 1. The y's completely cancel. So this is my final answer for that. Woo! All right. Second one. We're going to split it apart and deal with each fraction. a squared x y squared over ax. So the bottom of the fractions will all be ax's. And ax cubed. All right, so let's simplify. A squared over a is going to leave a single a on the top. X over x, those both cancel, and we have a y squared. So our first term will be ay squared. A over a cancels. X drops to a 2. a cancels, x cancels. Do we write 0? No. Anything over itself, 2 over 2 is 1, so ax over ax is also 1. All right, let's look at C. C is a type where we can have a single term, so we're going to proceed with the canceling. So 3 over 15 is 5. What else do I have? I have this x plus 1, and I only see one group of x plus 1s here, so I'm just going to write them down because I don't think they're going to cancel with anything. And then I'm going to look at 2x plus 1. And it's different than x plus 1. You can check that. And I've got to the power of 7 over the power of 3. So 7 minus 3 is 4. And then my last thing I have is an x minus 1. And I've got 1 here, 2 there. So that's to the power of 1, or just plain old like that. All right, our last one. I'm going to try and fit it across the bottom. 4x cubed y over 2x squared y minus 8, whoops, off to the races, x cubed y squared, that's hideous, over 2x squared y, always the same denominator, plus 2x squared over 2x squared y. So once again, you can use your exponent laws, or you can just kind of blow through. 4 over 2 is the same as 2. X squared, x cubed, be 1x left. Y over y is gone. First term, 2x. 8 over 2 is 4. x3 over x2 is going to make another x. And y squared over y is going to, bottom one will cancel, 2 minus 1, y. So I think minus 4xy. 2 over 2 is 1. X squared over x squared, those are the same, so they can cancel. And then I'm left with a y on the bottom, so that just looks like 1 over y. And you're done. That's it for simplification. Thanks for sticking with me.